Amid the deluge of statistics about COVID vaccines, it's easy to get overwhelmed. That's why Bermudian Dr. Ramon Arscott is a breath of fresh air. He draws easy-to-understand military analogies to explain how, armed with the vaccine, the body battles successfully against the virus. Dr. Arscott has a stark warning, too. Each time the virus enters the body of an unvaccinated person, it heightens the risk of mutation and prolongs the war against COVID. Dr. Arscott is a Harvard-trained plastic and reconstructive surgeon who also has a PhD in immunology. If you're still on the fence about the vaccine, listen carefully. You're basically saying your immune system is an army.
First of all, thanks so much, Dan, for having me, and for continuing the effort to just try and provide people with as much information as possible to help them to feel comfortable making a decision. I've come at this because a lot of people are just at the mercy of whoever's the loudest in the room, and sometimes it's just, okay, I'm going to trust this one versus that one based on gut feeling or who I feel more comfortable with, and less about an understanding of how things are. So if I can add to the understanding, then I hope that it translates into being able to discern what's conspiracy or not. And so I approach this, as I mentioned in the video.
Amid the deluge of statistics about COVID vaccines, it's easy to get overwhelmed. That's why Bermudian Dr. Ramon Arscott is a breath of fresh air. He draws easy-to-understand military analogies to explain how, armed with the vaccine, the body battles successfully against the virus. Dr. Arscott has a stark warning, too. Each time the virus enters the body of an unvaccinated person, it heightens the risk of mutation and prolongs the war against COVID. Dr. Arscott is a Harvard-trained plastic and reconstructive surgeon who also has a PhD in immunology. If you're still on the fence about the vaccine, listen carefully. You're basically saying your immune system is an army.
First of all, thanks so much, Dan, for having me, and for continuing the effort to just try and provide people with as much information as possible to help them to feel comfortable making a decision. I've come at this because a lot of people are just at the mercy of whoever's the loudest in the room, and sometimes it's just, okay, I'm going to trust this one versus that one based on gut feeling or who I feel more comfortable with, and less about an understanding of how things are. So if I can add to the understanding, then I hope that it translates into being able to discern what's conspiracy or not. And so I approach this, as I mentioned in the video, having done the PhD in immunology. So I was studying how the immune system works, and then working on vaccines or the immune response at Oxford to melanoma, to H1N1, and publishing on that. And in the same institution, the same place where the AstraZeneca came from. And so before getting into what the vaccine is, as you mentioned, I wanted to let everyone know that the immune system is literally an army. And like every army or police force, there is a general, head in the army, who directs everyone what to do, helps guide people in different directions. You got the snipers, the infantry officers, we call them killer T cells or CD8 killer T cells. The general is the CD4 helper cell. And then you got the detectives, the guys that go around looking for intruders, looking for trouble. And then you got the regular police squadron, the private on the front line, whose job is to cuff or arrest the intruder if he sees him. And when I say cuff them, handcuffs, I'm talking about antibodies. And so I just want to dispel, okay, this sounds like some weird thing, antibodies. Yeah, they have a few different roles, but you need to realize that they're there to cuff, they're the handcuffs for specific intruders. So every intruder, every time we create antibodies, we're creating handcuffs against that particular intruder. So if you understand at least those four members of the army, then you'll understand how your immune system actually responds to an intruder. When all these cells are made in the bone marrow, They then have to go to school to learn what makes you, you. What makes me, me. Why am I different from you? What makes up the building blocks of my cells? So that if it sees something that's not me, it raises the alarm. Okay? And they learn that in an organ called the thymus, which is very early in life. It actually gets much smaller as we age. And after that, the detective, what we call the antigen presenting cell, his job for the rest of your life is to look for anything that's not you or anything that's a mutated version of you, i.e. an intruder or a cancer. When it finds that cancer or when it finds an intruder, like a virus, it grabs him and takes him to the police station. And the police station is just lymph nodes in the neck, lymph nodes anywhere. If you hear about lymph nodes in the axilla or the armpit or the groin, they're just glorified police stations where the general sits, the detective presents and says, look what I found. And I found this virus, or I found this bacteria. I found this intruder. And says, look, and the general says, okay. And he calls in the police, the private guy, says, cuff him. And calls in the sniper and says, shoot him. But before you do that, I want you as a policeman, the B cell that produces handcuffs, to create a whole squadron of police with handcuffs specific for this intruder. So that if he ever shows up again, you don't need the detective to come and tell me he's here. You cuff him on arrival. And because there's so many of you, because you have a squadron of you now, no matter which door he comes in, mouth, nose, whatever, all over the body, you're there to cuff him. Sniper, same thing. The CD8 killer T cell, I want you to multiply and form a whole SWAT team of snipers so that if he ever shows up again, shoot him on arrival, you don't need the detective to come and tell me. The problem is, it takes 2 weeks to form said squadron and that SWAT team. So you and I, with just the irregular immune response, staying healthy, will deal with most intruders. But there are a few dangerous ones that can do a lot of damage in 2 weeks before you have that specialized force. Those are the ones that we want to vaccinate against. So what is a vaccine? A vaccine, scientists said, you know what? These ones that could do a lot of damage before you're able to form that squadron, can we give the immune system a heads up before you run into the real thing? And so they're like, okay, measles, mumps, rubella, polio. What they did, I depict the virus as a gunman, a burglar with a gun. They're like, can I give him the gunman without the gun? Weaken him, make him less dangerous. So you have the 2 weeks to form a response and a SWAT team to this gunman before he could hurt you. And that's what they did with those measles, mumps, rubella, polio. Those are what we call live attenuated vaccines. So when you have people say, oh, they're giving you the virus, I understand where that came from. Because yes, there were instances where they did that decades ago. Even today, we use that because it created that immune response. The flu shot, what did they do? They took the gunman, killed him, and then gave you the dead gunman. No, the detective finds him on the street because you got injected with it. He picks him up, takes him to lymph node. General, look what I found. And he says, okay, create a force if this guy ever shows up alive, that you cuff him and shoot him on arrival. And that's what the flu shot is every year. But that's not what the COVID vaccine is. It's neither a live attenuated nor killed vaccine. They said, how can we make this even safer? How can we give the immune system a heads up without giving you the virus? And so that's been the transition, the fascinating evolution of vaccinology over the last 50, 60 years. So for the last 30 years, they're like, there's this coronavirus. It showed up in 2003, SARS. Had just over 10% mortality. It showed up again in 2012. It was called MERS, Middle Eastern Respiratory Syndrome virus. Same corona. Had a 34.6% mortality. Then it comes back in 2019 as SARS-CoV-2. It's like Terminator 2. And they're like, okay, now it's got about almost a 3% mortality. They've been working on trying to get a vaccine for this thing for a long time. Wasn't last week. Wasn't last year. And even 10 years before that. So what did they do? They looked at it and said, what makes this gunman unique? It's like, wow. And I show you in a depiction, a gunman with a green hat, a blue jacket, brown shoes, a gun over his back. He said, this is the only one with a green hat. Suppose we just gave you the hat, not the gunman, whether dead or alive. Some vaccines are the gun, like tetanus. They give you the gun. So if anybody shows up with that, it's not even that. It's just the hat. It's just a little bit of protein from its clothing. And if you look at the virus, it looks like this shell with these spikes coming off of it. It's the spike, that little red spike. They call it the spike protein. Why is it a good target? Because that spike protein is what binds to your cells to get the virus in. It needs it to get inside you, get inside your cells. So like, okay, that's a good target. You can't do without it. So the chance of him shedding that spike protein is low. And if it changes too much, you can't do without it. So we'll target that. He's the only one with that kind of thing. So, but with that spike protein. So that's the green hat. That's the target. So that's what they gave you. So that if the detective finds this green hat, finds this spike protein, he turns it to the general and said, General, look what I found. I found this green hat. Calls the police and said, if you see someone walk in this door with this green hat on, you should cuff him. Sniper, shoot him. Create a squadron, create a SWAT team. The hat can't hurt you. It's not even the virus, it's just his hat. Okay? Now, we'll take it one step further. Now that you know that, look, they're not giving you the live virus, they're not even giving you the kill virus. It's not the flu or the MMR or any type. It's a different form and which is causing a lot of angst. Oh, this is different. It's actually safer. They noticed, because this is a fascinating thing, that police force that cuffs you, that gives you the handcuffs, the antibodies, they're really good at finding intruders on the side of the road, things that are circulating in your bloodstream and outside of your cells. The SWAT team, the CD8 killer T cells, they're really good at going after guys who got inside a cell, got inside what I call someone's house instead of on the side of the road. This is when I say, look, I need you to realize your entire body is a neighborhood and every cell is a house. And there are 37 trillion houses in this neighborhood. What's unique to viruses? They like to break into houses. They like to get in a cell because they have to get into a house or a cell in order to multiply, in order to replicate itself. Certain bacteria like to get into cells too. TB, tuberculosis, they like to get, those are intracellular bacteria. Other bacteria floating around. So you need a good SWAT team because you need someone who is going to go in and shoot somebody that's inside the house. They realized if all they did was give you the hat, you didn't create a good SWAT team. Not as good as if they gave you the whole virus. So like, can we give you the hat and get them to create a SWAT team that's as big as if we gave you the whole virus? And they found the way to do that was to put the hat inside a house. How do we get the hat inside a cell? Once we do that, then the alarms go off and they're like, oh my God, there's somebody else's hat in my house. Someone was here. That's a big alarm as opposed to finding someone's clothes on the side of the road, which is in the bloodstream, if you're following me. So to do that, they said, okay, I need to know how inside the house works. Now, all your houses, all your cells have little workmen inside. We call them ribosomes, and they're there to fix up the house and maintain the house, clean the windows and repair the bed and repair the cabinets if anything's broke, i.e. make proteins. And they know how to repair a house and build a house based on an instruction booklet that's in the house. A little manual that says this is what makes up Diane's lung cell or Diane's liver cell or Ramon's kidney cell. And that manual is called messenger RNA. So when people hear about, oh, RNA, it's just an instruction booklet inside the cell that tells your little workmen, the ribosomes, what makes you up. And they read it and they say, oh, I need to replace the bed, replace a bed, so on. Once they make something, they always put it at the door. They always put it in a basket at the outside of the cell so the detective can see what's inside. And that's how he knows whether something's wrong inside. But that's how it scans. The detective goes house to house, making sure that there's no intruder and there's no mutation. So they said, suppose we gave you the manual on how to make the hat. Gave it to these little guys. He makes the hat. No, the hat's in the cell. He presents it as like, oh my God, what is this doing inside? Alarms off, runs off, takes the hat to the general. General says, SWAT team, you need to make a whole SWAT team in case we find somebody with a hat like this inside another cell. So that's what they did. They gave you a manual, i.e. messenger RNA, on how to make the spike protein, i.e. the hat. Then they said, how do we deliver this manual to the body? Because it is so fragile. If you hear Dr. Karika Weldon, she'll tell you she studied this RNA all her life, all of her professional career. It's extremely fragile. So they need to have a shell that protects it when they inject it. And that shell is just literally fat. It's a lipid. Lipid is the medical term for fat that protects it and delivers it to the cell so that you can deposit in a cell this book, mRNA. Your ribosomes, your little workmen, take it, make the spike protein, make the hat, and then bam, huge immune response. That takes 2 weeks to build up the SWAT team. If Corona or SARS-CoV-2 ever shows up, you got the police at the door waiting. What's the difference between the vaccines? The main difference is that shell, that delivery system. Pfizer, Moderna, they made that lipid shell, that little bit of fat in a lab, like literally. Put it in, they can synthesize it and give it to you. Oxford, AstraZeneca, Johnson & Johnson, that vector, that shell that delivers the book was a little harmless virus where they took out the insides of the virus and just used its shell. Why did they do that? Because we learned how to deliver it based on viruses. Because that's how viruses function. We learned this from a virus because, for instance, COVID, what it does, or SARS-CoV-2, its spike protein is on its shell. It binds to the cell, releases its manual inside the cell, hijacks your workman. The workmen then have to use the manual of the virus to make more virus. It scavenges your entire cell. All the raw material basically destroys the house, moves on. So you're like, okay, if that's how viruses work, we're going to hijack that mechanism. See if we can get a shell to do the same thing. So AstraZeneca, Johnson & Johnson took a harmless virus called the adenovirus, took its shell, put the spike protein mRNA in, the manual how to make the hat, and gave that to you. Okay? So those are the main differences between them. And all the trials, why one takes 2 shots, why one takes 1 shot, it's based on the amount of SWAT team members they got after giving you the shot. And or they give you another one, they got a really good response, like, yep, that should protect you. Mm-hmm. And based on that trial, they said, well, is it 3 weeks apart? Is it 12 weeks apart? Well, they're going to tell you how they did it. Because they know based on that, they did it this way, so they got that outcome. So we're going to tell you, do it this way, and we know you'll get that outcome. Okay. So that's how your army gets ready. The army may not stop the burglar or the gunman from coming in, as in you get him getting on the road, i.e. you catching it. But once he tries to get in a house, or once he gets in, he's cuffed and he's shot. So you can get infected, but he can't go in and deliver his manual and hijack your gunmen, your workmen, and multiply. If he can't multiply, then he can't do the other thing that viruses like to do, which is mutate. That is a key point. Viruses mutate. There are millions of mutations of COVID right now. But there are only some that really raise alarms. So when I show mutations, I show you the gunman again. I say, okay, sometimes he changes because he's mutated, he's multiplying, and he might change his coat. I had a blue coat before, now I have a red coat, no problem. Sometimes he goes and picks up a bigger gun. No, you have a more deadly virus. Kills people easier. Sometimes what we worry about is suppose he changes his hat. Right now, it's a green hat. It's that spike protein. If it changes enough to a purple hat, what's my army looking for? What's my SWAT team looking for? Those of us who are vaccinated, they're looking for intruder green. If he shows up with a purple hat, he'll hurt you because they're not looking for that. So anytime there is a change in the hat, it raises alarms. The UK variant, the South African variant, the Brazilian variant, and now the Indian variant, what do they have in common? The spike protein's mutated. The hat is changing. So what do they run and look for? They look to see if we're still mounting a response. If our army will still kill that version, The good news, the hat's still green. It might be a green baseball cap or a green top hat and not a green turban, right? But it's still green. They still recognize it as the target. What we worry about is if it changes too much. The other thing, why does the virus change the hat? It's strange because remember I said it's the part that binds to us. It needs to get into our house. It's really like a key. It binds to this receptor called the angiotensin converting enzyme receptor. It's the lock that it binds to open up and get in a cell and deposit its manual. It's changed to be a more efficient key. So it can get into cells easier. So it makes it more transmissible. But if it gets in and your police is there and your SWAT team's there, cuffed him, shot him. Can't multiply, therefore it can't mutate. If you can't mutate, you don't give it the chance to become either more dangerous or become a new monster that we won't recognize. Right? So that's why we've gotten to the point where the CDC just changed a few guidelines. And how we roll it out, that can be a discussion. But the principle is that if you've cuffed him, if you've vaccinated and you caught it, and you cuff him and you shoot him, you can't multiply enough to pass it on, which is why you're less transmissible. You're less likely to infect someone else because the virus isn't able to just hijack this house, multiply, destroy it, move to the next long cell, because the long cell is the house it likes to attack. Multiply until you have a whole lot of viruses and you have enough to give to someone else. So it's less transmissible. And it also can't mutate. So as Dr. Fauci said, the vaccinated person is a dead end for the virus so far. The goal is to create, based on mathematical models, so many dead ends that eventually there's so few people left for it to multiply in because it's cuffed and shot in the vaccinated that it'll die off. And that's how they come to the term herd immunity, or community immunity as the premier calls it, right? Because if every 7 out of 10 people it gets into it cuffed and shot and it can't be passed on, dies in that person. And so we decrease the community transmission, we decrease the amount of virus in this community. So the take-home messages are, to this point, one, if you're not vaccinated and you catch COVID, you've allowed it to, and you may get over it, no problem. You may be asymptomatic. You may recover in the short term, and we'll talk about long haulers in a second. But you haven't just said, well, I'll take a chance and see if I'll get over it. You've made yourself the vessel in which you could create another monster. So when they said you're not just doing it for yourself, you're doing it for society and the globe, it's because we're rolling the dice every time we allow this thing to multiply. You could create the Bermudian variant. It could be the one that's picked up a bigger gun. It could be the one that changes the hat. And if it does, and the vaccinated are not protected, that is the reason we would need a booster. Because what would be a booster? I need you to give me whatever hat it is now, so that I now create the army looking for the purple hat, if it's a purple hat. We are not there yet. Look, if you Google whatever, all the variants, your immune response, the vaccinated immune, the ones, your army can still protect you against every variant that's out there, because the spike protein is necessary for this virus's survival. So it's changing, but it's still recognizable. The point of, if you're vaccinated and you're like, okay, up until now, you're like, now I know I can get infected, but I won't get the disease because it won't multiply. If you're not vaccinated and you do allow it to multiply and you actually get over it, people think that life and death are the real parameters. No, that's not just the real parameters. There's a Nature Medicine paper, I believe, from March 22nd. We talk about reputable sources. When I was doing my PhD, one did a Nature paper, You either wanted to publish in Nature or Cell or Science. These are all journals. New England Journal of Medicine, Lancet. There are these scientific papers. But there's a paper looking at what we call the long haulers. So you've caught it, you got over it, and they're showing that even 6 months later, a year later, it's not just affecting the lungs, it's affecting the heart, the kidneys, the brain, the skin. You're even seeing increased mortality. People are dying 6 months, a year later from the effects of COVID. Now, I mentioned the lung because I want to make the point that another thing unique to viruses is that each of them like a different house to break into. COVID, or SARS-CoV-2, the coronavirus, likes to break into the lung cell. That's why it starts there. That's why they get in the oxygen pulse oximeters to measure your oxygen level, because if it kills or destroys enough pneumocytes or lung cells, the cells that are in charge of exchanging oxygen and carbon dioxide, then you can't get the oxygen and your oxygen starts to fall. And if you see the chest x-rays of these patients, it is frightening. Okay? HIV, it doesn't like the lung cell. Which cell does it infect? Which cell does it break into to then scavenge? The general. That's the cell it likes, the CD4 helper cell. That's why when HIV breaks into the general and kills the general, you've now decapitated the army. You kill enough generals, you get acquired immunodeficiency syndrome, AIDS. So each of them have a cell that they like. COVID likes the pneumocyte, the lung cell. Okay, so that's important to know. But the long haulers increase morbidity, i.e. sickness, and increase mortality, i.e. death, 6 months, a year later. So it's not just whether I live or die. It's not just roll the dice, I'm young and healthy, I'll get over this. There's some unforeseen, quantifiable ramifications outside of just getting what people think is just like a pneumonia. So when we encourage vaccination, it's yes, to try and minimize the chance that you'll get sick in the short term. It's trying to minimize the chance you'll get sick in the long term. But say even that doesn't happen, it is the responsibility of not allowing yourself to be the vessel in which you've created a more dangerous virus because it's multiplied and changed, or a virus that now has changed the hat and everybody's susceptible again. And the world goes back into that cycle where we're back to where we were in March of, or January of 2020. There are still a lot of questions outside of this. Fertility. There was a debunked theory that the polio vaccine, one of them, there are two types of polio vaccines, using the continent of Africa years ago. Remember I said the live attenuated is like the gunman without the gun and the killed one? You have both types for polio. You have a live attenuated version, which is oral, and then you have the killed one that inject you with. The live one was affected fertility. And they proved that it didn't. But then it perpetuated. But that may not even be the origin of why they think they're linking infertility with vaccination here, right? First of all, that is the whole virus that they're giving in polio. This is just a hat. So you can't even compare them. But there was a letter written to the EMA, I believe. That's like the FDA of Europe, okay? By two erroneous claims. That the spike protein has a molecule called syncytin, SYNCYTIN 1. Now, syncytin, or syncytin, however you want to pronounce it, is a critical molecule for placental development. And so they're like, if you create antibodies against the spike protein, then you're going to create antibodies or handcuffs against the placenta. So there is no such thing. There is no syncytin on the spike protein. It's not like it even looks like it. No such, and they have debunked it over and over. It does not affect fertility. This thing about shedding the spike protein. Can't happen. Shedding was something that was seen when people multiplied certain viruses and they had so much viral load they could shed it. We can't shed the spike protein. And suppose somebody even did. It can't hurt you. It's the hat. There's no scientific molecular way for either giving you the vaccine to cause any response to infertility, because it just doesn't make molecular, it doesn't line up molecular wise, and it's been debunked in vitro, in studies, etc. So that's one. The extension of that is it safe to give to pregnant women? Yes. Is it safe if I'm trying to get pregnant? Yes. In fact, the studies show, they looked at, I think it was 90,000 women in the UK, I think, and over 50,000 in the US, who got the shot. Not only was it better for them, because if the pregnant woman is not vaccinated and they catch COVID, or corona, or SARS-CoV-2, I should say, they have a 1.4 times more likelihood of being admitted to hospital than somebody that was vaccinated. Then when the baby is born in the vaccinated person, they found the antibodies, the handcuffs in the baby, which means the baby is protected. It means if that virus ever tried to come around, the little baby got the handcuffs from the mom, is protected. So it didn't prevent fertility. It was protective for the mother and the child. Herd immunity. People talking about, I want to just emphasize here, we are not trying to replace living healthy. As a doctor, when people come to me as a surgeon, a reconstructive surgeon, I said, I'm a doctor first, then I'm a board certified general surgeon, and then a board certified plastic surgeon. So I need to make sure you're safe for surgery. Then I try and get the best result possible from a plastic surgery standpoint. As a doctor, I'm telling you, please eat properly. All your fruits, your vegetables, your vitamins, exercise. They're like, I'm just going to make sure I'm healthy and boost my immune system. Take everything to make sure my immune system's strong. Yes, you do that. Absolutely. The reason we put the elderly first, the vulnerable first, it's because at baseline their immune system wasn't as strong. But why do we say everybody needs to be vaccinated? Because there's certain viruses that even the strongest immune system, it will take you down. I don't vaccinate you against every virus on the planet. We don't give your immune system a heads up against every virus. We give you a heads up, a vaccine against the ones that could potentially hurt you or kill you. So I never call it alternative medicine. I call it complementary medicine. It's to complement you being healthy. Mm-hmm. Okay? So when I talk about herd immunity, and like, oh, I need to vaccinate you in order to count you in that group. Why? Because when you get naturally infected, yeah, you'll mount an immune response. But what we know is that Ramon and Diane may form handcuffs to different parts of this intruder. I might form handcuffs to the blue jacket. You might form, James might form handcuffs to the brown shoes. You might form handcuffs to the green hat. And each of us may form a different amount. I might form a lot of handcuffs against the blue jacket or the green hat. But we know the only protective antibodies are against the green hat. And we don't even know if you've made enough of them, which is why somebody can catch COVID. This thing mutates in someone else, changes to a red jacket, catch it again, because I'm looking for somebody with a blue jacket. We know the ones who get the green hat and form an army that's going to recognize the green hat, they're protected because he can't change his hat very easily because he needs the hat to survive. He needs the hat to get into the house. Those who get the virus, recover from it, we can't put them in the group as saying, okay, you're now immune, because I don't know if you have enough antibodies and if you've made the right amount of antibodies. If your SWAT team is looking for somebody with a green hat or with a blue jacket. That's why the difference between immunity based on vaccine-induced immunity and natural immunity, and why we count so and so for herd immunity. And why is it 70? Again, it's a mathematical model. Some viruses we need to get to 80% of the population. I spoke to whether you need a booster shot later on. And no one can say yes or no definitively yet. We know definitively if the hat changes, we're going to need a new shot. But why do I get a booster shot for the flu every year? But I don't get it for measles. The last time I got the measles shot was just before college. Got it at 5 years old, and before college. But the ones who are susceptible, the elderly, those of us who work in the hospital, they tell us to take the flu shot. Why? Because of how rapid it changes. Each virus, while it mutates, flu changes quickly. He might have had a yellow jacket this year. Next year is a blue jacket. So what is the flu shot? They find the first couple incidences, isolate the flu, and say, what does he have this year? Oh, he has a red jacket. That's what we're going to give you. We're going to kill him because it's a killed vaccine and give that this year. But not everybody gets the flu shot. So it gets a chance to multiply in someone else and change his jacket. And next year, it's a different form. So you get a different shot next year.
So for those people that, say that this is not officially approved, that, that the vaccines are under an emergency use authorization, that they're experimental, that they are new, they don't want to be part of the great experiment, what do you say to that?
All right, so great question. Let me start from the beginning where you said, it's been 30 years. It hasn't just been the RNA technology that's taken 30 years. It's like figuring out how to make that fat lipid nanoparticle to protect it. And maybe that's where the chip thing came in. Nano just means small particle, lipid, small particle of fat. Okay? That took 30 years. So that didn't happen overnight. They were testing it for 5 years in real people before all of this, because again, they've been doing it since SARS in 2002, MERS in 2012, and now the newest version of Corona. And when they saw how good it worked in phase 1, phase 2, phase 3 trials where they were working on tens of thousands of people, they're like, okay, we need to roll this out in the real world. What is required to get FDA full approval? Follow-up data on how it's affecting the real world, which they now have. Pfizer they're on the cusp of getting full FDA approval. It will be approved. Regarding those who said, I want to see what's happening, I don't want to be a guinea pig. If the 30 years of the research shows you that it didn't happen overnight, is not enough. If the fact that they did phase 1, phase 2, phase 3 trials is not enough, I'll put it to you this way. In March, when I started doing these talks, at that time, back in the middle of March, about 117 million people had been infected with SARS-CoV-2. At that time, about 2.3 million had died from it. So just about 2%. Now, today, if you check online, it's 164 million that have been infected. At the time when 117 had been infected and 2.5 million had died, 200 million people had been vaccinated outside of that. And you couldn't even count a paltry amount if there was any major side effects. And this was early March. Then they're like, okay, you know that if there are side effects based on decades of vaccine data, it usually happens in the first 6 weeks. We've been vaccinated for over a year now, right? In terms of from the studies till now. And they hadn't seen any. And then right on the back end of March, middle of March, they say, what about these clotting thing? Is the vaccine causing these clots and all? Should we pull back? The reason why they hesitated in the beginning to say it was the vaccine that was causing it is because SARS-CoV-2 causes clotting. They were trying to determine, is it the vaccine that caused it, or did the person get the hat and then caught COVID afterwards before they got their second shot, and that's what caused it? To give you the data, if you catch Corona currently, you have a 1 in 12 chance of getting a DVT, a clot. You have a 1 in 12 chance of getting a PE actually in the lung, clot in the lung. 1 in 9 in the leg. Okay? If you get sick enough to end up in the ICU, God forbid, 23% chance of getting a clot from the infection. That's 1 in 4. If there was a clot to come from the vaccine, they estimated it would be 1 in 250,000 is the chance. Maybe 3 to 4 in a million might get a clot. And just like in the beginning when they were struggling to figure out how to treat corona, they've now figured out what are the causes of the clots and how to treat it. Mm-hmm. So it is as rare as being hit by lightning compared to the 1 in 9 or 1 in 4 of getting it if you caught the infection. So the infection is way, way, way more likely to give you a clot than the vaccine. And if you're the 1 in a million person that might get it, they got the treatment for it. And they know how to test for it as well. Bottom line is the infection causes clots way more. And the vaccine is extremely, extremely rare. To give you one more nugget of comparison, if that disparity doesn't resonate, for any woman out there taking the oral contraceptive pill, 1 in 1,000 will get a clot from that. If you take a vaccine, 1 in a million might get a clot. 1 in 250,000. So it's not even comparable. And people take the pill every day. No one's running down the FDA to stop the oral contraceptive pill. To answer your question about those who said it's experimental, I don't want to be the guinea pig. Back then, we're about almost 250 million people have now gotten the vaccine, if not more. How many hundreds of millions need to get it before you realize I'm not the guinea pig anymore? I hope that is of some solace. With regard to the RNA technology, it can't integrate into your DNA. It is extremely fragile, right? It's a different book. You have your own book. The ribosome gets this little book. As soon as it reads it and makes the hat, it's broken down. It took 30 years of research to ensure that that is so. It's not gene therapy. Gene therapy is when they actually look at your genes and they cut out a piece and to get rid of something that could be causing you some congenital mutation or disease. This is not gene therapy. This can't integrate into your DNA. It's a little book that tells you ribosome or the workman how to make the hat, and then it's broken down. It breaks down so easily, it took us a long time to figure out how to just even get it there, which is with that little fat molecule. And if you go back to the original presentation with Dr. Weldon, she'll tell you everything in the vaccine. Actual vial, water, fat, a bit of salt to make sure that it's the same concentration as your bloodstream, and the book.
Is the result of this success that was so fast to attack this deadly virus part of the reason why people are so skeptical? It's unbelievable efficacy.
We've been trying to attack this gunman from when he first showed up in 2003.
Right.
Okay? Mm-hmm. So we've been trying to do that from then. The thought of, suppose we have a different way of giving the immune system a heads up. So for corona specifically, we've been trying to attack it from then. The thought of saying, can we give him the hat and not the whole gunman? That predated then. Why did I say it took 30 years? Why was it early 90s? Because they've been working on trying to give you the book and how to make a piece of the clothing since then. So what seemed to be quick was like, oh, this is this new type of vaccine. No, they just rolled it out. And why were they able to roll it out right after it started to go like this? Mm-hmm. One, they've got 30 years of backing, 5 years in humans. They've got the technology ready to go, and then they threw money at it. They're like, this thing is going to affect the world. And so normally when they're doing trials, they might like, okay, let's give you the manual on how to make the jacket, give you the manual on how to make the hat, give you the manual to make all the shoes, and see which one makes the best army. Phase 1 trial. Like, wow, the hat looks like it's the best army. Let's go to phase 2 with that. They did it all in parallel. But like, we're going to take all of them all the way. They had the time, the runway to do it, and then they had the money, and then the collaboration for all the scientists to talk to each other. In one sense, it didn't happen fast at all. In another sense, you're like, well, the rollout seemed like, well, it hit, and now we've got the vaccine. It's because we had the money and the collaboration for everybody to be saying, okay, I because when you say they sequence it in China, you need to look at it and say, what makes up this virus? Oh, he has a green hat. He has a blue jacket. That's what we call the sequencing. How does he look? Then they said, okay, how do I make the manual that tells you how to make these things? So now we know what it is. We know the proteins. Translate the manual, the RNA, to how to make those proteins. Then we'll do the trials as like, which part of this is critical to its survival? The hat. Then take that to phase 3 trial. When you have the resources and you have the technology that's already developed, gone, ready. So I have a full faith in the science because it wasn't rushed. The science was not rushed.
I think we are just so fortunate that everything seemed to line up at the right time. And I know, again, all kudos to the decades of science that obviously went behind it. But the fact, as you said, that you had the financing, you had the collaboration, you had the technology that had gotten to a certain point, and then you had, I guess, the sequencing and, but again, a lot of it boils down to I don't think there's never been anything like this as far as a worldwide collaboration and focus on something to this degree.
Well, the reason it had to happen, because suppose we were having this discussion in 2012 when MERS happened, when Corona cropped up in the Middle East, okay? It killed 1 in 3 people it got into, 34.6%, okay? And we weren't ready. Yeah. 6 years later, scientists have been scurrying. And they're like, okay, we're ready. Okay? And why was this one in the sweet spot of a virus? For the virus's sake, it's like, I'm going to hurt people. I'm going to have like a 3% mortality, killing people. But I'm going to leave 97% of people alive. So I have people I can multiply in. And I can perpetuate. Right. I can continue to live. I'm not going to kill the host. Too many hosts, I should say. Okay? So the virus had mutated in a way where it's like, no, the spike protein, i.e. the key to get into your pneumocyte, had mutated so it can get in a bit easier. It doesn't kill you. The gun is a big gun, but it's not a bazooka. But it's a gun that will hurt you and kill some people. So it's now morphed into something that seemed to have been able to transmit much easier, kill enough people, but leave enough alive that it continue to live on.
Right.
So thankfully, we've been working on this for decades. And everybody had to band together because of the implications of this thing.
Right.
The last time it hit this level, a century ago.
Right. And
we didn't have neither the technology or the collaborative know-how to say, hey, I figured out he wears a green hat. Okay, I'll sequence him. I'll tell you how to make the RNA, how to do it. Right. And then, okay, cool. I'm working on the shell. I got the shell ready to go. All right, let's go. That's different corners of the globe. The concern among some of us about infringements of rights, okay? And I get it, right? I get the fatigue of living this way. I get the pain that we're all going through of not just loss of life, but the economic impact. I gave this talk in other countries. I gave this talk in Jamaica. I did a Zoom call with members in Ghana, Benin, Togo, Niger, New York. And I talk about when it gets to a certain level and it starts to overwhelm the health system, not only are you consumed and running out of resources looking after the COVID patients, but the non-COVID illnesses aren't being looked after. And so there's this knock-on effect. But the shutting down of businesses and that is real pain. Now,